Okay, this is section 9.2, geometry and measuring arcs. It's on page 652. Okay, so yesterday we defined a circle. We found out it was all the points that are equal distance from a center point that's in a plane, and I didn't put that yesterday, but if I don't say it's in a plane, then it's a sphere. So a circle's in a plane. Okay, today we're going to do some more definitions. We're going to start with the circle, and we'll call it center B. And we are now going to draw two radii like that. We're going to call this point A and this point C. Okay. Now you can see what this does is it creates an angle inside off the center. Okay. And this angle is called a central angle. You need to know that. And this is angle A, B, C. It is an angle. Okay. Okay. Now, how big is it? We don't know. But this arc right here is a part of the circle, and that's what it's called, an arc. So I'm going to go ahead and call it an arc. An arc is a piece of the circle. So it's spelled A-R-C. Arc, it's where the central angle touches its endpoints, or the vertexes. I never really did tell you what the central angle is. It has an angle at the vertex. Excuse me. I totally blew that. It has the vertex at the center. Has the vertex at the central. That's what a central arc is. Now, I can have a lot of them. Okay, I can do this. Okay. Then I can make this one up here like this. Call this E, right? There's a theorem that says the sum of central angles. Okay? And if I number these, we'll call this 1, 2, 3, 4. There's 4 central angles. Then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals what? 360 degrees. That is correct. Okay, so let's take a closer look of how we can involve algebra here, because that's always exciting, right? Okay. This angle here is 20x. I'm sorry. Oh, I got you. This is 8x minus 4 degrees. Can you read that? 8x minus 4. This is 13x minus 3 degrees. And this is 5x plus 5 degrees. How could I solve for x? But I don't know this one.
Put another x. Can you add them together and then subtract them from 360?
You could, but that would just give you that one.
Can you just put that in, like put x in for that?
No, they're not vertical angles. This one's a little off. That's a great question. If these two were vertical angles, then you could do it this one and this one. Yeah?
Well, you could take 180
But I
minus
will tell you
28.
this. Say that again.
180 minus
half?
Isn't this this is a diameter, right? I'm gonna tell you this is a diameter. Now, does that change what you're thinking? Say, we have a diameter of RB. Go with what you were saying, Aubrey. Kind of. Use the other side. Okay, see this angle here? And this angle here? And this angle here? What?
Equals 180.
There you go. I don't need to know the whole thing if I know the diameter, right? Now, it would be, I could add them all up and said it was equal to 360 degrees, couldn't I? Okay? So now, if I change all this to plus and negative, I get 8x and 13x is what, 21x? And 5x is 26x? Is that true? And then I have a negative 7 plus 5 is plus a negative 2 equals 182. I subtract a negative 2. I get 26x equals 182. Nope, 182, right? And I divide by 26. I don't know if it comes out even, does it? X equals what?
Yeah.
7?
Mhm.
It did come out even. Okay, now if I asked you to find the angles, you'd plug them all in. And you could actually find then this angle by taking 360 minus all the rest of them, couldn't you?
Yeah.
So x equals 7 degrees. Any questions about that? Okay, so let's talk about arcs a little bit. Okay, we have 3 arcs that we're going to deal with. We have a minor arc. Okay, a minor arc. It is named with 2 points that are the endpoints. Okay? It is equal to the central angle that intercepts it. Okay? We have a major arc named with 3 points. The major arc is greater than 180 degrees and is equal to 360 minus the minor arc it shares endpoints with. I'll go over all this in a minute. Then a semicircle. And you guys probably know that a semicircle is exactly 180 degrees. It's named with 3 points. Okay?
What is
What-
the last 2 words on the major arc?
Shares endpoints with. Minor arc, it shares endpoints with. This should say with too, sorry. Okay, so let me give you an idea of what to do. And I'm going to try to keep this on the same board. Okay? Here's your center. Okay? Can you read that? Okay, if we take a look at this circle, X is in the center. This is A, B, C, and D. Okay, DB is a diameter. Line segment DB is a diameter. Okay, so a minor arc, and I don't know how to do this. I'm going to run out of room. Name a minor arc. Minor arc is is what? Okay, so what you do is you put this arc like this. This says that AB is a minor arc. It's less than 180 degrees. Okay? A major arc would be what? A what? DB is a semicircle, and you have to name it with 3 letters. So a major arc would be DBA. Okay, DBA goes from here all the way to here. It's over 180. What's another way I could name the major arc DBA? ABD, okay. What's another way?
Can you just say A?
DCA. DCA. The middle letter does not matter as long as it's between the 2 endpoints. Do you understand that? Now, what did you say, Dylan? Okay. All right. Now, if I'm going to name a semicircle, okay, I can name arc DAB, which is this one. And then I also have another one called DCB. You understand? Semicircles and major arcs have to be named with the same, with 3 letters. Okay? Now, I said that a central angle, a minor arc is equal to a central angle that intercepts it. So this right here is 90 degrees, right? That means that this arc is 90 degrees. Do you understand that? But you can't do a major arc that way. A major arc is done the opposite way. Let's take a look at CDB. CDB is this one right here. How big is CDB?
90 minus 360.
How about 360 minus 90,
That's
which is
270.
270 degrees? Okay, so I could say the measurement of arc CB equals 90 degrees. Then I could say the measurement of arc, and I got to use 3 letters, CDB, or I could use CAB. CDB is 270 degrees. Okay? Now they got to add up to what? 360. Okay? All right, questions? All right, let me give you an example. A little more, let's try this one. Okay? The top letter is P, this is Q, and this is M, and this is N. Okay? I want the measurement of MQ, but first of all, tell me, MQ is what kind of arc? Major, minor, semi?
Minor.
How can you tell without even looking at the picture? There's 2 letters. Okay, so how big is MQ? If this is 115, I didn't finish it out. That's 115 degrees. How big is arc MQ? How many degrees? 65 degrees. Can you tell me how you got that?
180 minus 115.
All right. All right, so now I want the measurement of MNQ. What kind of arc is that?
That's minor.
MNQ?
Oh, no, that's major.
It's a major. Can you tell me how big it is?
Would it be 2
Tell me how you got 295.
360 minus 65.
360 minus 65, or you could do 180 plus 115, either one, right? Okay. Congruent arcs have congruent arcs are arcs in the same or congruent circles that have the same measure. Why do they have to be in the same or congruent circles in order to have the same measure? Can you have two circles, one really big and one really small, and they have the same degrees, but they're not the same, are they? No. Okay? A bigger circle, the arc will be bigger, even though it has the same degree measure. Okay? So it has to be in the same. Minor arcs intercept congruent arcs. Okay, if they're the same measure. All right. Turn to page 654, please. All right, take a look at the picture. We have female participation in sports. Okay. How big is the measurement of arc EF? How would I find it? Soccer. Soccer. It's 14%. How big is that arc? How would I find it? What's it 14% up? 100%, right? How many degrees is it?
180. Or,
The whole circle is how big?
360.
360. So how many degrees would I find? How would I find the degrees of 14%?
14% of 360.
How do you do 14% of 360? Can you say it's too dark, isn't it? Tried this before. I take 0.14 times 360, correct? So how many degrees is that?
50.4.
50.4. So you can do a circle graph. You can do the how many degrees it is by taking the percent times 360, correct?
Yes.
Okay. What are adjacent arcs? Why 0.14? Kellen?
Zero meters.
You gotta move the decimal. You gotta change it to a decimal. What do you think adjacent arcs are?
Arcs right next to each other.
That's right. They have a common point. One common point, actually. Okay. Take a look up here. Can you tell me two arcs that are adjacent?
And MQ.
Arc NM and arc MQ, right?
Mm-hmm.
Right? And if you add those up, they equal the whole NQ, don't they? So this arc plus this arc equals the whole arc, right? That's the arc adjacent postulate, okay? All right. One of the last things we're going to talk about is arc length. Arc length is the actual distance a piece of it has. And we know that the full circumference of a circle is what? From yesterday. What's the formula?
Diameter times line.
Okay, I'm going to go 2 pi r. All right, I think this book, because we're normally given the radius. Okay, so to find arc length, and where you use the letter L. okay? All right? The arc length is equal to how much of the circle you have, right? So we gotta take something times 2 pi r. So the arc length equals the degrees, right? And this book uses x out of 360. So if you're given why x out of 360 degrees? That's the fraction I have, isn't it? How many degrees I have out of 360 times the circumference? You understand that this is how you find arc length. Let me give you an example. Let's say that I had a circle and its radius was 3 centimeters, okay? And this angle right here was 45 degrees. Can you read that? 45 degrees? And this is AB. So to find the length of AB, the length of AB, okay? Now that's different than the angle measure. The angle measure of AB is 45 degrees, correct? But I want to know the actual length of it. How long is it? I would take 45 out of 360 times 2 pi times the radius, which is 3. Now, I don't know if you know this, but 45 over 360, that can be simplified to what? 1/8? Is that 1/8? Does 45,
Yes.
okay, it's 1/8 times 6 pi. Notice how I'm simplifying the problem before I plug it into my calculator. You can plug it into your calculator all you want, but I'm just simplifying it. So divide, what I get is, divide by 2, I get 3 and 4, so I'm getting 3 pi over 4. Take 3 times pi and divide it by 4 and tell me what you get in terms of centimeters. Take 3 times pi divided by 4. And I could have done that up here.
2.3. Wait, what do you want it?
2.36,
Yeah.
okay, centimeters. Kagan, do you understand that?
Yeah.
The length, now I realize that this is 45 degrees, but that doesn't tell me how long it is. It tells me how many degrees it is. The length from here to here is 2.36 centimeters if the radius is 3 centimeters and it intercepts a 45-degree arc. Okay? So here's what I want you to do. All right? I want you to do the same thing. I'm going to draw a new circle. You're going to tell me how long it is. I'm going to go like this, and this is 120 degrees. This is A, and this is B. And this is 8 feet. Your center is 0. The radius is 8 feet. Would you please tell me the length of AB, arc AB, to the nearest hundredth?
What's the one?
120 degrees, 8 feet.
What is the 0?
That's 0. It's not 0. That's letter O.
Oh.
Oh, I get you.
What do you want it how you do?
Nearest hundredth.
16.76. What you got here? Feet.
What did you get? 16.76?
Yeah.
Okay. 16.76 feet, right?
Mhm.
Okay. All right. You see how to find arc length. All right. We're not going to talk about radian measure, but there is another way to measure angles. It's by radian measure. I'm not going to discuss that. We may later if we get a chance, but it's a whole different ball game. For what in this book it doesn't do it, but in art it is a different ball game. So your assignment is page 656, numbers 14 through 26, and that is all. And then 28 through 44 even. Somebody wants to write that on the board. It's worth 36 point. I would like it due at the end of tomorrow's period. Okay? All right.